Hi guys, this is lesson 10.2, dealing with quadratic functions. After today's lesson, I would like you to be able to graph quadratic functions in the form of y equals ax squared plus bx plus c, and then we're also going to move into quadratic inequalities. Really nothing is different there than what we've done in the past, so we'll use what our prior information that we've learned with today's lesson as well. So let's begin. The axis of symmetry is the line with the equation x equals negative b, or the opposite of b, over 2a. What I mean by the axis of symmetry, it's the line that goes right down the center of the parabola, and if you folded your parabola in half on that line of symmetry, or that axis of symmetry, it would lay directly on top of each other. One thing I want to point out is that your a value, the one in front of your x, it tells you, remember, if your parabola points upward or downward. And then your c value tells you what your y-intercept is. This equation will also tell you what the x-coordinate of your vertex is, which is on your axis of symmetry as well. So let's talk about the steps that we're going to follow in order to graph the quadratic function. First step. You're going to use that same formula I just gave you, x equals the opposite of b over 2a, to find your axis of symmetry. And then you're going to plug in a point into your x value to find your vertex. Step 2, you're going to find two other points on the graph. You're going to use your y-intercept, which we know is where? Or what do we know about our y-intercept? You guys should be able to recall this from previous classes. Your y-intercept, number one, is your c value, but it's also where x is 0, y is intercepting, or your parabola or line is intercepting your y-axis. And then we're going to substitute another value in for x that's on the same side of the vertex as your y-intercept. And so you need a couple of points on one side of your axis of symmetry to make it a parabola. And then step 3 is you're going to reflect those points across the axis of symmetry and then connect your dots. If all of this seems like a foreign language, you'll pick it up real quickly when we start doing a few problems, I hope. So let's start with our first problem. We've got y equals negative 3x squared plus 6x plus 5. We're going to find our axis of symmetry with that equation I gave you, which is on your screen. The opposite of b, well, b is 6, so it's negative 6, and then you're going to take 2 times a. A is negative 3, which is going to be negative 6. And so you know that your x value is 1. So your axis of symmetry, you're going to draw a dotted line at 1 through your x-axis. Now you're going to plug that value of x, 1, into your x values in your quadratic function, and you're going to solve. So when x is 1, what is y? It's 8. That gives you your vertex. Your vertex you're going to plot at 1, 8. Right here. Now we're going to move on to the second step. The second step was to take a point that is, well, I always do 0 because that's my y-intercept. I plug in 0. I know my y-intercept also is c, so I really don't have to plug in that 0. But just to show your work, you're going to get y is 5 when x is 0. Plot that point. Now, on that same side of the axis of symmetry, you're going to choose another point over here that you can plug the value of x in to find your y. So, we're going to pick an easy one. We're going to use negative 1. And I always use negative 1 or 1 depending on what side of the axis of symmetry I'm on. When x is negative 1, y is negative 4. We're going to plot that point. Now we're going to reflect those points across the axis of symmetry. Connect your dots. And there's your parabola. And we saw that our a value was negative 3, so since it's negative, it opens up downward, and that's what we ended up with. So that's an easy check. Let's try another one. Now's a good time for you to pause and see if you can do this on your own. Okay, let's try the problem. First thing we're going to do is we're going to find our axis of symmetry using our equation. X is the opposite of b over 2a. We get 6 over 2 times 1, which is 3. So we are going to graph our axis of symmetry with a dotted line at 3. Now we're going to plug that x value of 3 in to find our vertex. Plug it in, We get y is 0 when x is 9, but we already knew that our y-intercept was 9 because that's our c value. We're going to graph our vertex at 3, 0. We know that our y-intercept, like I just said, is 9, so we could plot that at 0, 9 right here. We're going to choose another point on this side of the axis of symmetry. I choose an easy one. Let's try 1. When x is 1, y is 4. Plot that. Reflect those two across the axis of symmetry. Connect your dots. There's your parabola. Again, the a value is 1. It's a positive one, so our parabola opens upward. Good job. Try this one on your own. Okay, first thing we're going to do is use that axis of symmetry equation. X equals the opposite of b over 2a. We get negative 4 over 2 times 4, which is negative 1/2. Graph your axis of symmetry at negative 1/2. Plug in negative 1/2 for x to find our vertex. When x is negative 1/2, y is negative 4. Plot your vertex on your axis of symmetry. Now, we are going to plot, well, first of all, we're going to plot our y-intercept, which we know is negative 3. But if we plugged in 0 for x, we would find y is negative 3, in case you didn't remember that our c value was negative 3. We're going to choose another point on this side of the axis of symmetry, which I'm going to choose 1. When x is 1, y is 5. Plot that point, reflect them across the axis of symmetry, connect your dots, and as we've done in the other ones as a last-minute check, our a value is a positive. So since it's positive, our parabola opens upward. What's different about this problem? Right, we have an inequality sign. Now, the couple of things that we need to remember when we're dealing with an inequality is we need to look at what area we're going to shade, which is with the greater than or less than portion of it. And then our parabola either is going to be a dotted parabola or a solid parabola, depending on if this equal sign is on the bottom. And here it is, so we know it's going to be a solid filled-in parabola. So let's solve this just like we've solved our quadratic equations, but this is a quadratic inequality. First thing we're going to do is use our opposite of b over 2a. So the opposite of b is 6. Well, 6 is b, so the opposite of b is negative 6. 2 times a is going to be negative 6. So we know that our x value is 1. We're going to graph our axis of symmetry there on 1. Now we're going to find our vertex. Plug that 1 back into our quadratic inequality. And when x is 1, y is 8, that's our vertex. You need to graph that. Once you graph that, now we're going to graph our y-intercept. Our y-intercept we can find by making x 0. We also know that it's at 5 because it's our c value. We're going to plot that point. We're going to now find a point on this side of the axis of symmetry. We're going to use negative 1. And so when x is negative 1, y is negative 4. Plot that. We're going to still reflect those over the axis of symmetry. And I said it was a solid line because it has an equal underneath. Now we have to determine, are we going to graph above the parabola or below the parabola? How do we know what is above and what is below? Look at your vertex. If it is greater than, then it's going to be the area that's above your vertex. If it is less than, it's going to be the area that is below your vertex, whether it opens upward or downward. Since it's greater, we're going to shade this area above the parabola. So any solution that falls in this blue area or on the parabola is going to be a solution to this quadratic inequality. Let's try another one. I want you to try this one on your own, so pause, and I will come back to help you in a moment. Okay, so now the first thing we're going to do is the opposite of b over 2a, our equation to find the axis of symmetry. We're going to get 6 over 2 times 1. We're going to get 3 for our axis of symmetry. Draw a dotted line there. Plug your 3 back in for x so that you can find your y value. This is where we're going to find our vertex still. So we get when x is 3, y is 0. We're going to plot that vertex. Now we're going to graph our y-intercept, which is going to be 9. when x is 0. Plot that. Choose a point on this side of the axis of symmetry. I would choose 1. So when x is 1, y is 4. Plot that. Now, if you look up here, this should tell you if it's going to be a dotted or a solid parabola. You should have determined that it's going to be a dotted parabola. So let's reflect those points across the axis of symmetry. Connect them with a dotted line. Now we have to determine, are we going to shade what's above the vertex or below the vertex? This says greater than. So we're going to shade the area directly above the vertex, which is going to be inside the vertex only. So now the solution to this quadratic inequality is any point or coordinate in the blue area, but not on the parabola since it's dotted. Let's try another one, and I'm just going to walk you through this one. You can pause at any time and do this on your own. We're going to use the opposite of b over 2a. We get negative 4 over 2 times 4, which equals negative 1/2. We're going to draw our axis of symmetry there, plug in negative 1/2 for x to find our vertex, and we get y is 4. Graph your vertex at negative 1/2, negative 4. Now we're going to find our y-intercept. We know that that's negative 3, so we are going to plot our y-intercept. On this same side, we are going to take 1 and plug it in for x. When x is 1, we are going to get y is 5, and we are going to plot that point. We are going to reflect those across the axis of symmetry. We know that this is going to be what kind of line? A solid line. Good job, because we have that equal sign underneath. Last step is to determine what area we are going to shade. It says less than or equal to. Look at your vertex. The area below is less than, so we're going to shade this area outside the parabola. The solution to this quadratic inequality is any point or any coordinate that falls in the blue area or on the parabola. I hope this makes sense to you. If you have any questions, come back and talk to Mr. Hare or myself. Have a nice day.